Hello everyone, I hope you all doing well, and today I'm gonna deal with ANSYS Fluent. In that, this case study is a turbulent flow analysis. As you can see here, by just referring this slide, the turbulent flow Reynolds number is more than 4000. For laminar it is less than 2000. Okay, and the turbulence will be like this. The vorticity of the particular fluid indicates the turbulence inside the flow. And here, this is the case study. I'll just consider the circular cylinder with respect to the flow in a pipe. The diameter consider 100 mm, and how the turbulent flow will occur inside we'll check. So the next case study is this with respect to the angle 12, 20 and 32, how the airfoil gonna create the turbulence flow and the streamline flow we're gonna see. Okay, I'll just quickly jump into this. So to create this studies manually, you can have two options. One is component system and analysis systems. So you can directly drag this Fluent system, Fluent. You can able to work on all the setups at once, but right now I don't want to use it. So I want to create all these steps manually. So I'll directly drag and drop the geometry by component systems. So you can create only geometry here first. So I'll directly jump into this design modeler. So in the design modeler, by using this, I'll create a rectangle with the circular surface, surface inside. I'll refer this XY plane for now. I'll jump into the sketching, make it normal to view. Select the rectangle and just right. Before that, better to change the inner system. Yep, that's fine. Start from the center, I'll draw it like this, and now itself I'll add one more circle inside, which should be somewhere here. Okay, after that you go ahead with the dimensioning general, and here I'll define these 1, 2 and 3, the diameter, and from here to here it should be something, from here to here it should be something. So here it is available. The first one is h1 should be 500 for me. Okay, and v2 should be somewhat 100, and if it is 100, L4 will be 50, right? This should be for me 300. No, 200 is enough, and the diameter should be 50. It's too much. 25. Is that fine? Yep, the dimensions I have specified. I'll just zoom out. Okay, you can see this is how it is. Diameter D3, I'll just increase it to 50. We'll see how the change is gonna happen here. So my sketch is ready. I'll directly jump into this sketch 1. So go to create concept. I want the surface from the sketch. I'll just select this entire sketch from here. I'll apply this material. I don't want to add the material right now. I'll keep it frozen. The thickness should be 0 as I'm creating the surface 2D. Yep, the surface is ready, right? I can go ahead with the part here. This is already available. So yep, so this is my geometry. I'll close this design model for now. So as I'm done with that, I'll add the mesh. So I'll just drag and drop the mesh with respect to this geometry. So this geometry will be copied here, and with respect to that you can able to mesh your surface. Let us see how to do that. It's taking time to load up the modeler. Yeah. It's here. Okay. Yep. It will load up something to. Sorry for the inconvenience. Some disturbances there from outside. Kindly cooperate. Yep, so this is what we got here. I need to mesh it with respect to my requirements, so let me directly jump into the mesh. Here I'll add the mesh controllers. Before that I'll just rename the selections, so I'll jump into the edge selectors. So this should be pipe for me. Right click and use create name selection and write it as pipe. Okay, so this should be inlet for me. I'll add it inlet. Done. So then there should be the outlet. Write it down. Out let. The naming should be done because these are the things which will account into the Fluent, which are the boundaries, which are the inlets and all, so that matters here. So this is my wall. Okay, done. So I think this is done, right? Pipe. And now I'll just choose the fees, and thus I'll rename it as Fluent. So there should be my fluid, right? That should flow. FLUID. Yes, my selections are done. So here let me directly jump into the again edge selections. Unit system, you should note it down, millimeters. So I'll just select these two. I'll add the mesh controllers sizing. So the size of these two edges should be with respect to divisions for me. Now I'll choose the divisions. I'll add it as hard, and the number of divisions should be for these two 50, right? So I'll make it 100. I think it's more. Make it 50. Then for these two edges, right? Correct. Sizing should be with respect to what? Divisions. The behavior should be hard for me, and the 500, right? Per mm it should distribute for me. It's okay. Then for this particular edge, I'll use the sizing that this should be hard again, and the division should be more. So let me see 500 this time. Okay, well, so let's see what happens here. Just generate the mesh. Okay, it might take much time to generate the mesh, and then I'll just pause it. Okay, the meshing is fine here. So let me just add again one more mesh controller here, so it should refine the mesh at this location. Okay, mesh refinement should be 2, 3. Let me just check. Generate the mesh. Yeah, so this is fine, no issues now. So this is what we require. So if you want to change it again, you can go ahead with that, but right now this is fine for me. The 100 here, I made it 50. Here if you want, you can increase it, make it 200. So again regenerate it. So this is what our meshing is. So this is done. So again I just named these selections for my convenience. That is also fine. So we can just switch. No issues with the meshing. So this much refinement is fine for me for my turbulent flow analysis. Yep, so this is fine, no issues. Well, go ahead with the next step. So once meshing is done, I need to deal with the Fluent. I'll just drag and drop it here. the setup, I need to define it. So I need to again update this mesh. So I'll just update this particular mesh, and then the software automatically patch up the setup now. Now it will take time to update the solution, so let us see. So once this is done, I need to define the setups, inlet flow as well as outlet how should be, and then with respect to that we'll just define the study parameters, and then we'll run and we'll interpret the results. I think it's done. Okay, fine. I'll just double click on the setup now. I'll just start dealing with this. I need the double precision. Just go ahead with, don't change anything. Just click on OK here. Once you do that, the Fluent one more pop-up will be there. Standalone, sorry, independent window. Here it will load up the particular setup which you have created. So it will load here. Still loading. Yeah. Yep, our geometry is ready with respect to our meshing. So now I'll just drag this one somewhere here like this so that we can analyze these things. Fine. So let me first deal with this mesh. I'll check the meshing. So checking, it's done, no issues. There is no report the quality. Aspect ratio is 4.5. It's okay. And then let me jump into the model. Here I need to deal with the flow. It should not be laminar. As I am dealing with turbulent flow, I'll just choose key epsilon for this, and the epsilon model should be standard here for me, and the standard wall thickness I'll choose. I'll click on OK. I don't want to change anything here. And once that is done, go ahead with the material. Here I need to change the fluid as air. I'll click on create, and from the data I'll load up the water, the liquid water. I'll choose it. Okay, and I'll copy this over there, close it. This is fine. So we have defined the water for our and solid will be aluminum, no issues with that, and close it. Cell zone, the fluid will be my cell zone. Whatever the fluid you have defined, no, the name selection that automatically takes, and that should be what? Air, not air, exactly water should be there as my fluid. Fine. So we have defined our fluid, and boundary conditions will be here. So I need to define the inlet. So I'll edit the inlet. So inlet should be with respect to what the magnitude should be 0.25 for me, or I'll take it 0.20. Let me just make it 0.30 meter per second. You can calculate using 3600 divided by 60 conversion. I think kilometer per hour you can convert. So right now I don't want to deal with that. It's okay. The specification method with respect to K and K epsilon, no. I'll go ahead with the intensity and the diameter. So hydraulic diameter should be for me 100 mm. Sorry, it's in meters, so I need to define it properly. It should be 0.1, right? Yep, so fine. So I'll go ahead with this. Inlet, I have defined the velocity should be 0.3 meter per second. Outlet should be fine, but with respect to hydraulic diameter I'll name it as 0.1. Don't want to change anything. This is fine for me. We are done with the inlet and outlet. The fluid interior, no need to change everything as we have defined the fluid. It should have the inlet velocity that much and it should flow over there, and it should give me the results with respect to the turbulence with respect to this pipe. So that is done. Go ahead with the solution part, and here the solutions. So in the methods, simple, I'll use it, and I don't want to change anything here. This is fine for me. And monitor reports, no need right now. If you want, you can go ahead with that. Residuals, here with respect to absolute criteria, conversion should happen with respect to x velocity, y and cape in continuity. Epsilon should be, that also should converge. So with respect to what? 0.00001. This should be my value. 1 2 3 4 5, so one more 0, I'll add it. Okay, to get the exact accuracy, I'll use these values to converge my results. Okay, I'll just copy paste them over there. So once you define it, click OK. If you want, you can add the report files and report plots if you want, and then let me directly jump onto the initialization. So it should be standard for me, no issues. So not the hybrid one, so as I'm dealing with the simple initial values for x, y, z, no need to do. The initialization is done. Okay, once you do that, directly jump into the run calculations. Okay, and here my iteration should be 1000. And this number of iteration, it should converge the results. I'll just click on calculate so that it should run the processor. Your calculation is going on, so it is converging the results as we can see here. So the K epsilon got converged, everything is getting converged. So it might stop, I think below 200 iterations. No, it's going on. Let's see. I think I given the factors and the residuals too much, so I have reduced it. No issues. I don't think it will converge. It's again increasing. Okay, here comes the convergence. Still, I thought it might converge within just 140 iterations. The factors in the residuals, I just defined it wrong. Let me just check once, okay? The solution is complete. Okay, so in the graph it shows it is converging, so no need to worry about it. So this is converged, everything is converged with respect to our values. So I'll just close this. I'll update this here only, update the mesh setup and all, no need to restart. And I'll directly jump into the results. Okay, and here I'll choose the graphics, the contours. So I need to be dealing with pressure for now, static pressure. I'll just show you. If you won't select the filled one, get the results with respect to the lines like this. So right now, if you want to deal with the filled one, just select M7 display. So this is the static pressure. It is here. So next one, if you want you can just save it. For now I don't know how to save it, so I'll just deal with the velocity magnitude. And this is the velocity, how it is having the maximum velocity is at this corner. It is 0.69. And then I'll just check the turbulence, see how it is taking place over there. And this is the turbulence, it is more over this region. And next thing here is the pressure only. The pressure with respect to the total pressure. First we'll check the coefficient of pressure, same thing. And the dynamic pressure, the same. The total pressure will be like this. Okay, so this is the graph with respect to total pressure, and it is 105 pascals. And then so these are the few counters. We can go ahead with that. So I'll just close this one. So with respect to vectors, we'll check how the distribution is going on here. The arrows, the velocity distribution should be there. I'll just click on display. So this is how the vectors gonna see. So if you want to increase the scale, you can go ahead with that, 20. And this is how it looks. And now if you want to change the criteria with respect to pressure, this is the pressure distribution. Turbulence will be there like this. Okay, and here if you want to change the style as filled arrow it will be like this. And even headless will be like this. This will show how the changes is happening here. And then with respect to harpoon, so there are few settings, you can just do that and you can check how it is making the flows. Filled arrow, better one is arrow only, so you can increase them, so you can scale it up to 50 and you can check it how it is just representing the things. Okay, and this is with respect to velocity. And the pressure is this pressure distribution. So this is how we need to deal with this particular vector plots. And then same thing with the streamlines and particle tracks. So if I just select this particle track, it won't produce the particle tracks here, because as we are going to deal with only 2Ds. So this is all. I hope this video will help you a lot to deal with the turbulent flows. So let me just switch again here, the results, display this velocity distribution. So I'll change it to vorticity, that is turbulence, and this is how it happens here. And thank you all for watching. So I hope this video might help you to recall how to do the turbulence flow analysis. Thank you all.